Hello guys and welcome back to my channel Interview with Bunny, and today we will be starting with a brand new playlist, and that is on system designing. And the topic that we will be discussing today is a very commonly asked question for any system designing round, and that is the URL shortening. So URL shortener or URL shortening is a very commonly asked question in the system designing interview, and probably you can find this solution everywhere on the internet. But this video is special because over here in this video, apart from only discussing all the possible solutions to solve this problem, I will teach you a very important framework by which you can solve most of the problem on system designing. And here in this video, we will go through all the possible solution to solve this problem, and we will see what can be the pros and cons for each and every solution. Because over internet, you can at least found 5 to 6 possible solution for this video, and maybe everything is right, but there are some limitations over there. And here in this video, we will discuss all the limitations, and at the end, I will provide you a hybrid solution that will be very much optimal, and with the help of that solution, I can guarantee you that you can clearly pass any of the system designing round. So without wasting much time, let's get started and let's see what are the system designing approach by which we can solve this problem and we can clear the interview. So without wasting much time, let's start with the first video of our system designing playlist, and today's topic is URL shortener like Bitly. So before going to the solution of this problem, let's first understand the problem statement and how you should approach this problem. So the problem statement that is given over here is you have to design a URL shortener like Bitly. So if you are not aware of what is a Bitly, so Bitly is a website which provides you a shortened URL of all the long form URLs. Means, for example, here is a URL that I have provided to Bitly, that is the link of my Facebook account, and here Bitly have shortened this entire URL into only a 5 to 6 character word over here. And if I just try to open this URL, you will see that I will land to my Facebook account page. And here if you look carefully in the address bar, you will see that though we have given this URL, this shortened URL, but Bitly have redirected us to this longer form of the URL. So you can definitely see that there is a one-to-one mapping between this long form of the URL and the short form. So the problem statement is you have to find out or design a system that will do or perform this functionality, that whenever you provide a long form of the URL, you have to apply some logic to make it a short form so that it will be very easily accessible for the end user. So this is basically the problem statement. So let's see how we will solve the problem. And here in the system designing interview, the way or the pattern that we will be following is a clear 5-step process. So let's see what are those 5 steps. So the first thing that we have to do is you have to gather the requirement. So what happens in a system designing round, the interviewer will give you a very vague or a basic question. So over here, as you see, they will just tell you the very simple line like design a URL shortener like Bitly. Now it is your responsibility to gather all the information that what is the real ask of this question, because maybe you are not familiar with this Bitly application and you might not have used this feature anywhere. So in the system designing round, it is completely your responsibility to ask the clarifying question to your interviewer so that both of you are on the same page regarding the requirement of the question. So the first clarifying question that you should ask to your interviewer is to understand that what this Bitly actually does. And once your interviewer tells the real functionality of the Bitly, which is nothing but this one, then you have to go with some clarifying question to understand that what is the thing that he wants you to design. And based on that, you have to create and move with the first step of designing, and that is gathering the functional requirement. So let's first list down all the functional requirements that are suitable for this question. So to save our time, I have already listed down all the functional requirements that can be possible for this interview. So let's first go through all this requirement. So here if you see, the first requirement for designing a URL shortener is you have to create an application which will create a short URL from a long form of the URL. Means you have to provide a solution something like this, where the user will provide you a long form of the URL and you have to give a shortened form of the URL in return. And the second most important functional requirement is whenever the user types this URL into your address bar, he should get redirected to the original URL from this short form of the URL. So these two are basically the most important functional requirement for designing the Bitly application. Now apart from this, there can be few more functional requirement for this application, and that is you have to design a solution that will support a custom URL. So here if you see, if I open the Bitly account and if I try to use their application to shorten a URL, and here if I paste my Facebook account, here you will see it have automatically created shortened version of the URL, and this has been generated automatically. But here the interviewer can ask you an additional feature that instead of randomly generating the shortened URL, you have to give the user a provision to create a custom URL. So for example, here instead of generating something like this, I could have given an alias like ASD. So I should have the provision to create a custom shortened URL. So that can be one of my requirements. And maybe the interviewer tells that this will be a premium feature, means whoever is a premium customer to your application, only those will have the ability to create a custom shortened URL. And another requirement can be the expiration date. So for example, the default expiration date for a shortened URL is 90 days. But for a premium customer, you have to give the functionality where they can provide the expiration date of the URL. So I hope this is clear that what is the functional requirement for this application. So this will be the first step of solving the problem, that is to gather all the functional requirement of the system by discussing it with the interviewer. Now let's go to the second step of solving this problem, and that is gathering the non-functional requirement. So the non-functional requirement of the system states that what are the characteristics of the system. Is all the statement like availability, reliability, consistency, all those things comes under division of the non-functional requirement. So let's see what can be the non-functional requirement for this system. So the first and the most important non-functional requirement for this system is low latency. Means whenever a user try to shorten a URL, they should get the response in the least amount of time as possible. That is called the latency of the system. Similarly, when the user enters the shortened URL in the address bar, they should get redirected in the minimum possible time. So here latency should be a key point or the key non-functional requirement for this system. And here it is better, instead of just writing the low latency as one of the non-functional requirement, here you specifically mention that where you want to apply this feature. Means here you are expecting the low latency on redirect as well as on the URL creation. So it's better if you have time, please do mention that where this non-functional requirement will be applicable, so that your interviewer understand that you have the knowledge of where to apply this non-functional requirement during the designing of the system. So let me mention it over here. And another important thing, whenever you are discussing the non-functional requirement, try to quantify each and every requirement that you are suggesting. So for example, whenever you are telling a low latency, you should specify that what is the amount of time you are expecting. So for example, you want that your customers should get redirected or should able to create the URL within 200 milliseconds. Means within this 200 milliseconds, the functionality should get performed. So in this way, whenever you are discussing the non-functional requirement, just discuss it thoroughly at what is the non-functional requirement you try to solve and what is the number that you are targeting. Now let's go to the next non-functional requirement, and that is the scale of this system. So you have to ask your interviewer that how many users will be using your application. And believe me, gathering this number might look quite redundant, but based on this number, we have to take a lot of critical decisions while designing the system. And here in this video only, we will see that how this number will change the designing aspect based on the total number of users we are targeting. So over here, let's assume that your interviewer tells that this application should be supported by 100 million daily active users. And your application should be able to transform or shorten 1 billion long form URL. So you can see this is a huge amount of scale that we are talking to. And based on this scale, we have to determine that which database to use, which architecture we should follow, and many things. Now the next possible non-functional requirement is you have to ensure that whatever the shortened URL you are returning, that should be unique. So your shortened URL should be unique. So this is another requirement. And the last but not the least, another non-functional requirement that you have to discuss in all the system designing round, that is the cap theorem. So let's see how this cap theorem will be necessary for any system designing round. So the cap theorem tells that whenever you are designing a distributed system, you have to either compromise with the availability of the system or you have to compromise with the consistency of the system. So here if you look carefully, the scale of this system is quite huge and it is quite obvious we cannot rely our system on a monolithic application, because monolithic application tells that you have deploying the entire source code or entire application in a single server, and obviously a single server cannot have the ability to scale this much, means 100 million active users. So it is quite obvious you have to go with the microservice architecture where you can scale your system based on your requirement. And whenever you are telling that you are going with the microservice architecture, means you are going with the distributed system. And whenever you are talking about the distributed system, your cap theorem tells that whenever you are creating a distributed system, you either have to compromise between consistency and availability. Means your system should be either highly available or it should be highly consistent, but you cannot achieve both of them together. And here we have to discuss with the interviewer that what we are compromising, because this is very crucial. And here if you look carefully into this application, our application demands high availability, not consistency. Let me tell you why. So for example, whenever you are trying to shorten a URL, you're obviously expecting that your Bitly website should work always. So it is very obvious your website should be highly available, because if your application is unreachable or it is down, definitely you will lose your user. Also, whenever they are trying to do a redirect by typing the short form of the URL, your application should be readily available to transform that short URL back to the longer URL. Otherwise, it will be a bad experience for the user. Now, what about the consistency? So the consistency tells about the read after write consistency. So for example, in a banking account or a ticket booking application, we need a consistent system. Means whenever someone books a ticket, after that, no second person should be able to book the system. So the read after write should be accurate. Means no two users should be able to book the same ticket. But here for this application of URL shortener, we have to ask ourselves that whether do we actually need a consistent system or not. Because here what consistency tells that is whenever you are shortening a URL and sharing it with someone, the second person who is opening the shortened URL should get redirected to the longer URL in the 0th second. Means there should not be any delay. But this is actually not applicable over here, because obviously the user who is generating the shorter URL will require some time to share that URL to the friends and families with which he want to share. So there will be a small gap between creation of the URL and the time you are hitting the URL. So here you have to understand few of the basic requirement of the system, and based on that only you have to make the decision. So here I hope you are clear that why we have to give the priority of the availability of the system rather than consistency. So here what we'll do, we will give the priority of the availability more than the consistency. So if you look carefully, though we are telling here that the consistency of this system should be lower than the availability of the system, but keep in mind, we are also estimating that the redirect should happen within 200 milliseconds. So it is not allowed that you keep the user waiting for an undefined period. So you have to also make it a bit consistent, and for that what we will do, we will try to make a eventual consistent system. Means it might not happen that you get redirect on the 0th second after creating the URL, but rather it is allowed to have a small delay of 200 milliseconds or so to get redirected. And for that what we'll do, we will describe this type of system as a eventual consistent system. I hope this is clear. And since this is for the first time or the first video I am creating, that is why I am explaining all these things in so much detail, because remember this point, during your system designing round, time is a crucial thing and you have only 45 minutes to perform this entire system designing. So keep in mind, all this requirement gathering of the system should be done within 10 to 15 minutes of your discussion. So whatever the details that you want to take from the interviewer, try to take it within the first 10 to 15 minutes of your interview. And that's it. Do not waste too much time on requirement gathering. Otherwise, you will just gather the requirement and you will not be able to provide the solution to your requirement, which will create a negative impact for your interview. So here we are done with the first step of our solution, and that is the requirement gathering. So let me list it over here. So this is our first step, that is gathering the functional and the non-functional requirement of the system. Now the next step of solving any system designing problem is identify the core entity of the system. Now, since this application is quite a easy and a basic application, you can see that there are not a huge amount of entities that are related over here. And the only three entities that are possible to identify are the short URL, the long form of the URL, and the user who is performing the action. So those three are the main core entity of the system who are directly involved to this. So let's list down all those three entities over here. Now, since we are done with the two important steps of our designing, now let's move to the third important step, and that is the API creation. So obviously, since here you are creating an application, you have to mention all the API endpoints that are relevant to design this application. And very frankly telling, if you have listed down all the functional requirement properly, listing down the API endpoint is quite easy, because most of the time it is just a one-to-one mapping. So here if you see, the first functional requirement is you have to create a short URL from the long form of the URL. Means you have to give a provision to the user to do so. And how you can do so? You have to you have to publish a REST endpoint by which you can perform it. So here, since you have to create an endpoint, that is, you have to create a shortened endpoint. So obviously we will create a post endpoint. And how our post endpoint will look like? It will look something like this. So this is the path of our URL. So here we have the version of the URL, and this is the URL endpoint that we are targeting. And what it returns the shortened URL. And since this is a post call, so obviously there should be body of this request. And what we will pass in the body, that is the long form of the URL. So here in the body, we will be passing long form of the URL. And apart from that, you have two optional fields, and that is you have to provide a custom URL option and also a custom expiration date, which is only available for the premium user. So this cannot be a mandatory field but an optional field. So how we will represent it? We will represent it with a question mark. So it will look something like this. So this is how our first API endpoint will look like. So I hope this is clear. Now the next URL that we need to design our system is to redirect the user to the original URL from the short form of the URL. And since here we are passing the short URL and in return we are trying to retrieve the value of the longer URL where we want to redirect, so obviously this will be a GET call. So here we will be having our second REST endpoint, which will look something like this. And what it will return? It will return you the original URL, means the long form of the URL. And that's it. We are done with all the API creation that are required to design your system. And here if you look carefully, as I've already told you, there is a one-to-one mapping with the requirement and the API. So here you can see for the first requirement, we have created this API endpoint. And for the second requirement, we have created the second endpoint, that is this one. So here we are done with the third step, and that is the API creation. So now since we have gathered everything, that is the functional requirement, non-functional requirement, and we have already find out what are the core entity of our system, what will be the REST endpoint that will support our application, let's now start with actual designing of your application, which is the core meat of this video. So let's proceed with the fourth step of our solution, and that is the high-level designing of this system. So truly speaking, high-level designing of the system is very easy if you have managed to do until this point. That is the requirement gathering and the API creation. So let's see how we will do it. So the main thing or the main point that we have to focus on the high level designing is we have to build a system that should be capable enough to perform the functional requirement of the system. Let me tell you what I mean to say. So here if you look carefully, the functional requirement of the system tells that we have to create a system which will allow us to shorten our long form of the URL to the short form. So obviously there should be a client or the user who is requesting. Another, there should be a server which will create all this computation, and there should be a database where we should store all this value. So let's jump into this high level design. So here what we will do, here we will draw some simple blocks to design our functional requirement. So the first requirement is we need a client over here who is making the request. So this will be our client. Now the next thing is we need a system which will be responsible to convert this long form of the URL to short form. So obviously we need a backend server. So here we will declare a box, something like this, which will be our server, means our backend system. And the responsibility of this system is we have to generate the short URL. And once the short URL is generated, obviously we have to save it somewhere. Otherwise, we will not able to track that for which longer URL we have created the shorter URL. And if we cannot track that, it is impossible for us to redirect the user to the long form of the URL. So obviously, we need some database over here to save both the long form of the URL and the short form of the URL, and we have to create a map over there. So what we need here, we need a database. So let's see how the request is flowing over here. So here the client is making a request to our server to create a short form of the URL. So let's assume it is making a call as generate URL, and here he is passing the long URL. And let's assume that this server is doing some magic to create a shorter URL. And once the shorter URL is generated, what it is doing? It is simply saving this shorter URL and the long URL in the database, and thereafter in response the server is returning the shorter URL that it has generated. So here in the response what we will send, that is the shorter URL. I hope this is clear. So here the user is making the call to generate URL, and here it is passing the long form of the URL, and here in return the server is sending back the short form of the URL. So this is basically the first requirement of our system. Now the next requirement of the system is the user should get redirected to the original URL. So for that what happens? Once the user types the shortened form of the URL, the request will go to our server, means a redirect call will go over here, and in return what server will do? Server will first check the database, and it will check whether this short form of the URL is already generated and saved in our database or not. And if it is there, what it will do? It will retrieve this bigger form of the URL, and it will send this in the response body of the call, and thus it will complete total data flow of our API. So let me just properly redraw it. So here you can see this is how it will look like. I hope this is clear. Now let's see what we will save in our database. So the first thing that we have to save is the user metadata. So for example, we have a premium set of the customer. So for that what we need all the metadata of the user. So here we will be having a user table in our database, which will have some metadata over here. So this will be our first table. Now the second table, that is the most important table, is the URL table, which will be nothing but a map of the shorter URL and the longer form of the URL along with the custom URL and the expiration date of each and every URL that are there in the system. So here we will create another table called as URL table, and here we will be having 4 attributes. One is the short URL, next is the long URL, next is the expiration date, and the custom URL. So basically these are the 2 main tables that are required to design our system. And that's it. This is the total high level designing that you have to do to design your system. So here if you look carefully, we have not done anything too much complicated. What we have done, we have just converted this entire requirement into a pictorial view. Means we have a client which is making a call into our server to generate or convert the long URL into a short URL. And what our server is doing? Our server is making some computation, and once it generates a shorter URL, it then save it in the database and it returns the shorter URL in response. And thereafter, once the user enters the shorter URL, another call comes to our server with the shorter URL, and then we are checking whether the shorter URL is present in our database or not, and if it is so, then we are sending back the longer form of the URL in response, and from there we are redirecting the user to the original URL. So this is the core concept or the core data flow of the application which we have represented in this form, and thus this is the high level designing of the system. Now, since we are done with the high level designing, now let's go into the main thing, and that is the low level designing of the system, where we will reveal everything of this design. Means we will see what database to use, because here if you see, we have abstracted everything. We have not explained that what type of database, whether it is a MySQL database or it is a NoSQL database, whether it's a MongoDB, Cassandra. We have not specified anything. We have just abstractly told that we need a database. Similarly, here if you see, we have just told that here we just need a server which will convert the long form of the URL to a short form. But how we will do it, we have not explained anything. That everything we will discuss in the low level designing. And believe me, that is the main important thing on the system designing. That is how you convert a high level designing to a low level designing, and you explain it to the interviewer. So without wasting much time, let's deep dive into the low level designing and the last step of solving the system designing problem. That is the number 5th step, and that is the low level design. So let's start with the low level design. So the first thing that we will do, we will copy this high level designing from here and we will paste in our low level section, because here we will be using this same template and we will enhance each and every functionality over here to see how each and every component will be working. So let's start with the first component and the most important component, and that is this server component, because this server is the critical part of our system, because this server holds actually the real concept that how we will shorten the long form of the URL to the short form. So let's see how we will do it. So over here, I will tell you 4 to 5 ways by which you can shorten a URL. So here we will start with the basic implementation, and going forward, we will see what are the pros and cons for each implementation and on what situation we should implement that. And thereafter, we will increase our complexity in the designing, and ultimately we will design a system which is highly scalable, highly reliable, and highly consistent. So let's start with this design. So the first approach that we will use to shorten the URL is a very basic one, and probably that is the first idea that comes to any candidate, and that is the encryption logic. So let's see how we will do it. So over here, if you look carefully, this is the problem statement that we have to solve. Means given a long form of the URL, we have to shorten the URL to 5 to 6 characters. So this is basically our problem statement. And here if you look carefully, for each and every URL that we are encrypting or we are making it shorter, this part of the URL will be same, because this is our domain name. So the only part that changes over here is this part. So here this part is actually the string which gets mapped to this longer URL. So over here I will just remove this so that it will be easy for you to understand. And if you look carefully, we have to write some encryption logic to achieve it. So for example, here there is another website called Amazon.com. And let's consider that this is the shortened form of the URL for Amazon.com. So in this way, we have to find out some encryption logic to shorten this URL to this form, and thereafter we can simply store it in our database, so that whenever a user comes up with this encryption, means this shortened URL, we will simply iterate over our database and we will try to find out that what is the long form of URL that it is associated to. And if we find out the long form of the URL, we will simply return this URL and we will redirect the user to this one. Clear? So this will be our first logic and the most easiest logic to implement. So the first logic will be somewhat our encryption logic. Now how we will do it, we will definitely see. So the first way of doing it is like encryption logic. So let's now see how we will achieve it. So what we will do, we will encrypt the entire long form of the URL over here, and this encryption logic will return us a string from this long form of the URL to a short form. So this is what we want to achieve. So let's now discuss which encryption logic should we use. So if you go to the internet, you will find there are lots of libraries that are easily available on the internet that does this encryption for free. And you can easily use those libraries for free to design your encrypted string. And the most popular encryption libraries that are easily available on internet are MD5, SHA-1 and Base64. So these are the most popularly used three encryption logic by which we can easily encrypt our long form of the URL and we can easily find out a short form of the URL from that. So let's first see how these libraries actually work. So over here, if you go to the Google and go for this MD5 hashing generator, you can see a library something like this, where here if I just paste this URL, for example this one, and click on generate, you can see it have formed an encrypted version of this long form of the URL. So here you can see this MD5 hashing have returned us a 32 character encrypted string and this SHA-1 have returned us a 40 characters encoded string. Now comes a problem. That is, if you look carefully, the problem statement that was given and you have discussed with the interviewer, that is, we have to generate a short form of the URL from the long form, but it should be of 5 to 6 character length. But the encryption that had been provided by the MD5 or SHA-1 is a 32 or a 40 character length. So there is a problem with the length of the encoded string. But we can easily solve this problem by a simple operation. That is, instead of taking this entire string, what we can do, we can simply return the user only the first 6 characters of the string. That will easily create an encrypted string of 6 characters. So the problem statement is solved. So what we are doing? Here we are simply taking the long form of the URL. We are using MD5 or a SHA-1 encrypted logic, and here the string which it is returning, we will just take the first 6 or 7 character from here and we will simply return it to the user. Great, right? Our problem seems to be solved. But believe me, there are some major problems over here. Let me tell you one by one. So over here, if you look carefully, the encryption logic that MD5 hashing or the SHA-1 is using is quite versatile. But there is a problem, that is, we are not taking the entire string. Rather, we are just taking a 5 or 6 character from here, which is actually causing the main problem for us. Because here we have estimated that we are doing an encryption for 1 billion string. So here 1 billion string should get encrypted with this logic, and from there we only have to take 6 character from here and then we have to return the string to the user. But this causes a major problem because the way this thing is getting encrypted, we do not know, because here we are totally dependent on the encryption logic provided by the libraries. Now the problem might arise. For example, here we are encrypting thousands of URL from the internet. Now, for example, maybe we are encrypting this string. So for example, for this one, it have generated this one, and for Amazon.com, it have generated something like this. So based on this MD5 logic, though these two strings are unique, but since we are cropping the first 6 digits from here, you can see the first 6 digits are not unique. So if you have understood it correctly, both this URL will both get encrypted to the same short form of the URL. And this will cause a duplication over here. And our primary goal of this problem is to avoid duplicates so that no two users get the same short form of the URL. Because very obvious, otherwise we cannot map it properly. So obviously there is a flaw with this pattern. Now let's see how we can resolve this. So I hope you got the problem statement, that why we cannot rely on this way of solving the problem. So the easiest way to resolve this problem is, whenever a URL is getting generated or encrypted in this way, we will simply save the key value pair in our database. So for this short form of the URL, this will be the endpoint. Now when the next request comes for this URL, that is for the Amazon.in, since our encryption logic return us this encrypted string, what we will do, before we give it to our end user, we will first check that whether this short URL is present in our DB or not. So we will scan our entire database and we will check whether our DB consists this short form of the URL or not. And if that short form of the URL is not available, means that URL is unique, we can simply return it to the user. But in case this short form of the URL already exists in the database, we can surely assure that there already exists a long form of the URL mapped to this unique ID. So this short URL will not work. So at that time, what we can do, we can simply regenerate this MD5 encryption one more time with some appended key, and we can get another string from that. So that can be one of the approach. But if you look carefully with this approach, there is a high chance of collision over here. So let's estimate this and understand that what will be the possible negative scenario with this approach. So for example, here we are having our server over here. And let's take our encryption library takes 1 millisecond to encrypt. And once we are doing this encryption, what we are doing? We are simply storing it in our database. And you know, database operation is a expensive operation. So whenever you are calling a database, so obviously it will take time. So let's assume that it takes 5 milliseconds. So here what we are doing, we are getting a long form of the URL from the user. We are encrypting it, which is taking 1 millisecond. And then we are saving it to the database. And let's assume over here to scan the entire database, it takes 10 milliseconds. So here we have three operations. One is we are encrypting the string, one is we are sending it to the database, and another we are scanning the database with 10 millisecond latency. So here for the first time when we are encrypting this URL, our encryption logic took 1 millisecond to encrypt it to this form, that is 9191C0. Now what we are doing, we are first checking that whether it is available in the database or not, which is again taking a 10 millisecond. And if that is not there, means that is a unique key, then we are saving it in the database and we are returning it to the user. So our entire operation over here took 16 milliseconds. Fine. Now for the second URL for Amazon.in, first we did an encryption over here, which took us 1 millisecond. We checked the database, whether the encrypted form is present on the database or not. And here we have found that there is already a string that is present in the database. So what we have to do, we have to again come back into our server and we have to again regenerate. So obviously 16 millisecond is already passed. Along with that, we are again regenerating our string, means we are again encrypting. Again, we are going to the database. We are checking that that new URL that is formed with the second encryption, whether that is also present or not. And if that is not present, we are again coming back and giving the response to the user. But here if you see, it again took 16 more milliseconds to perform an encryption logic. So for the first operation, it was 16 milliseconds. For the second operation, it took 32 milliseconds. Now, if you have understood it right, we are not sure that how many collision that will happen over here with this approach. Now, if we are thinking over here for a 1 million use case, this 1 million URL, there can be multiple number of collisions over here and this latency can increase significantly. So maybe for a particular user, there will be 10 to 15 collision and we have to keep on regenerating the string, check the DB, and if it is already present, then we have to again regenerate, and in this way, and it will keep on doing so, and that will be a very bad experience for the user. So very clearly we cannot go with this approach for a huge large scale application. But obviously this will work, and where it will work, if your use case tells that you do not have to encrypt this amount of string, means your problem statement does not include 1 billion URL, then you can simply go with this approach. So this was our first form of the implementation. So what we have done, we have simply used a simple logic, that is encrypting a long form of the URL with some encrypting logic, and the resultant that is getting generated, we are simply cutting it or splitting it for the first 6 to 7 character. We are checking in the DB that whether that string is already there in the DB or not, and if it is there, we have to again regenerate it, otherwise we will return it to the user. So this was the first way of how you can shorten your URL. Now let's see what can be the second way of generating the short form of the URLs from the long form. So if you go over the internet and look for the solution of this shorten URL system designing problem, you can see there are lots of other approaches by which everyone is solving. Some of them are very basic in nature, and I'm intentionally skipping all those things because somewhere they are telling that you have to go with some random number generator, but obviously those will definitely fail because we have to scale it for 1 billion users. So there are a lot of trivial approaches that are already there on the internet, and you can easily go through those to to understand all those approaches. But over here, I'm going with some of the critical and the most efficient way by which you can solve this problem, because these are probably the best answer that you can tell to your interviewer, and you can easily showcase to your interviewer that you are not going with the entire crowd and you have some other thinking capabilities and other way of designing. So it is better to know all the ways of designing this short URL, but remember, you have only a limited time during your system designing interview, so do not waste your time in solving the problem with some trivial approaches, because otherwise you cannot give the best solution within that 45 minutes. So let's jump to the second solution, or the second best way of solving this problem, and that is with the help of the counter. So let's see how we can solve this problem with the help of a counter over here, and what can be the pros and cons for that approach too. So the next approach that we will be following, that is with the help of the counter approach. So the logic to use a counter over here is like, whatever the URL that we are receiving in our request, we will simply return a number in the response. So for example, whenever our application opens for the first time and our first URL comes for the encryption, we will simply return 1 for that URL. Similarly, once the second URL comes for encryption, we will return 2 for that. The next one will be 3, and so on. And with this approach, we can clearly tell that no two URL will have the same unique key, because obviously we are using a counter over here, and this encryption logic is totally in our hand. Means whatever the request is coming into our server, we are simply incrementing a counter and we are simply returning it to the user. So obviously each and every request should be unique, and thus we do not have to implicitly check our database to see that whether that unique ID already reside in the database or not, because we know it is an auto increment number, so obviously it have to be unique. So with that approach, what we did, we have saved a lot of time, and that is we have saved this 10 millisecond over here to go to the database and scan the entire database to see whether the ID is duplicate or not. So with this approach already, we have dropped down our latency of the system from 16 millisecond to only 6 millisecond. Means here what will happen? Simply a request will come to your server, then the server will check in their local storage that what is the value of the counter, and based on the value of the counter, we will simply send it in the response, and as well as we will save it in the database. Simple, but there will be another problem over here. Let's understand it. What can be the problem with this approach? So as I was telling you, to implement this algorithm, what you have to do, we have to simply keep a counter over here in the local of the server. So here there will be a counter variable in your local, and each and every time a request comes and hit the server, we have to increment this counter, save it into the database, and then we have to return the response from here. And in this way, each and every request will get a unique ID over here. But there is a problem. Over here, if you look carefully, we are telling that we have to scale for 100 million active users. Now, it is very obvious that if we are going with a monolithic application, which is over here right now, means we have a single server over here, a single server can never handle such a huge amount of requests. So what we have to do? We can only do so by two ways. One is the horizontal scaling and another is the vertical scaling. And here, if you look carefully, vertical scaling cannot be a best option, because to handle this much of traffic, we cannot have that amount of hardware capacity to do so. So obviously we have to go with some better approach, and that is with the horizontal scaling. And how we can do so? With the help of the microservice architecture. Means we will be replicating this simple service into multiple number of pods, and we have to deploy it. Now let's design it, and then we will see what can be the possible problem with that approach. So let's take an example. Here we have a client, and since we are going with the microservice architecture, we should able to handle 100 million active users. So over here we have to have a lot of replication of our pods. So let's take an example. We have 3 instances of our application, and here at the end we are having our database. Now, as you already know, since we are going with the microservice architecture, so somehow whenever the client sends a request to a server, we have to somehow split that request into all this server in a systematic way. And for that, what we need a load balancer over here. I hope this is clear. So here what is happening? A request is coming first into our load balancer, and here the load balancer using some algorithm will split the entire load, that is this huge amount of traffic, uniformly across all the servers that are deployed into our backend. And which algorithm we can use? We can simply go with the simple approach, and that is a round robin approach. So here we will write the algorithm that we will use over here is the round robin approach. And let me remind you one more thing. Whenever you are implementing a load balancer, do tell your interviewer that why you need a load balancer, what can be the functionality of the load balancer, and which approach you should be using in the load balancer. Now what will happen? This load balancer will simply distribute our traffic across all our servers over here uniformly. So the first problem is done, that is scaling for this 100 million daily active user. So right now our system is capable of dividing and handling all this traffic in a distributed way across all the server, and all the server will be uniformly working together and can handle this amount of traffic. Fine. Now what will happen? Once the requests have been generated, it will save it in the database. I hope this is clear how this system is working right now. Now let me tell you what can be the possible problem that can happen with this counter approach. So if you have already understood, there is a problem that will happen with this counter approach. So that is, each and every server that we have introduced over here will have a local counter on each and every machine. So for example, when this server boots up, this counter value is initialized with 0. Similarly, when this boots up, it is also having the counter value as 0. This is also having the counter value as 0. Now, for example, you are getting a request from the client and it went to the server number 1. And here the counter value is 0 right now. So what will happen? It will simply return the 0 as our response, and it will save in the database. Now for the second URL, let's take an example that again it went to the server number 1. So right now the value of the counter is 1 for this. So here again this server number 1 will return 1 for this response and will save it in the database. Now maybe for the third request, maybe it didn't went to the server number 1, rather it went to server number 2. At that time, what will happen? The local value of the counter in server number 2 is 0. So this server will also return 0 as the response, and thus we have created a duplicate record in the database. I hope this is clear. So this approach will again fail. Then what can be the solution? Let me tell you the solution of this problem. So the solution of this problem is very simple. Rather than keeping the counter in the local, what we can do, we can keep the counter in some global variable. And how we can save it in a global variable? By using a cache. So what we'll do, here we will use a cache, maybe a Redis cache. So here we have the Redis cache, and this counter right now will not be present on each and every server, rather it will be present over here. Now in this case, whenever a server is getting a request, it will not check the counter value in the local, rather it will try to find out the global counter variable. Means it will first check the value from the Redis cache, and thus based on the value of the counter, it will send the request to the user. So each and every time whenever a request is coming into our server, the server is first checking our Redis counter, and thereafter it will send the response to the user. I hope this is clear. So here you can see, with this approach, all our problems are more or less solved. Because over here, if you check the latency of the system, this is also pretty low. Because here you can check, once the request comes into the server, we are not going to the DB. Rather, we are going to the Redis cluster, and our accessing a cache is a very quick job. Let's assume it might take only 2 to 3 milliseconds to respond the value of the counter. So you can see here, instead of going to the database to check the duplication, we are simply going to our Redis, and then we are returning back the value over here. And since Redis is a single threaded application, so it doesn't matter whoever the server it is requesting to, the value will be always atomic. So with this solution, this problem will get definitely solved. But if you look carefully, there is a very critical problem, and that is here we have a single point of failure since we are having a single instance of Redis over here. And if by any chance this Redis instance goes down, our entire architecture fails over here, and there is no way we can generate new IDs for the new URL that are coming, and our system internally fails over here. So what can be the solution? The solution can be we have to go with some Redis cluster. Means apart from using a single instance of Redis, we have to go with multiple instances of Redis. But with that approach, there will be another problem, and that is the same problem that we were facing over here with the server. That is, each and every instance of the Redis will have a separate counter variable, and once one of them is down, you will get the data from another Redis instance, and there will be again a duplicate problem over here. So I hope you are clear with that why this system designing will also fail at some point. But believe me, if you can give this solution during your technical interview by mentioning this constraint, you will definitely clear the interview, because with this approach you are telling the interviewer that though you are implementing it this way, but you know what can be the pros and cons of this solution. And since you have a very limited time during your interview, this approach can easily solve this problem. So if you are simply a senior software engineer or a junior engineer, go with this approach. You can easily clear the technical interview. But apart from this, there are a few other things that you have to design and you have to keep in mind. Let me do all those things first, and after that, I will tell you the third way of designing this system, which will be a very reliable solution, and with that solution, probably there will be no problem with that approach. But before that, let's first enhance this design so that it fulfills all the functional and the non-functional requirement of our problem statement. And thereafter, we will see the further enhancement that you can do to solve the problems that we are telling over here. So here, if you look carefully, we are telling that we are targeting for a scale of 100 million daily active user. And if you think it logically, though we have 100 million active user, but every one of the user are not encrypting the URL. Maybe there will be 20 to 30% who are actually encrypting the URL, and most of our other users are using our application to convert our short form of the URL to long form, means for getting redirected. So obviously here, if we are computing both the redirection mechanism and the generation of the URL in the same server, we cannot scale this application in a meaningful way, because here in the server, we are actually doing two operations. One is the encryption and another is the decryption. And here we have seen that only maybe the 20% of our daily active user is using the feature of encryption. And the rest of the audience, which is a huge audience, are using 80% of our resources for decryption. So it's quite obvious we have to scale this decryption logic more than this encryption logic. Because if we scale both the system in the same pattern, so obviously there will be lot of resources that will get wasted, because all our encryption logic will not get utilized properly, and thus we will end up utilizing a lot of money. So what we will do here, we will subdivide this logic of the server into separate microservices. One for the encryption and another for the decryption. So let's see what we are doing. So here our first server will be encryption server and the next server will be our decryption server. I hope this is clear. So here you can see we have divided the component into separate parts. Means here we are having the two server. One is the encryption servers, which is responsible for only for encrypting and which is talking to the Redis cluster, creating the URL and returning it to the user. And here we have the decryption server, which is simply getting the short form of the URL, checking the DB and just simply returning it back to the client. So here we have solved another problem, and that is separation of concern. Means this server one will be responsible for encryption only, and this server will be responsible for decryption only. And now what we can do, since our encryption server will be hit by 20% of the active user, so what we can do, we will scale it accordingly. Means, for example, we will take maybe 3 instances of this encrypted server, and since our decryption server will be hit by 80% of our traffic, so we obviously need more instances of this server. So maybe we will create 5 to 6 replication of this server. So here if you see, based on the utilization of the server, we are scaling it accordingly. Now there will be one more problem, that is, here if you look carefully, though everything is working fine, we can still optimize the solution a bit. And that is, here if you see, whenever a new URL is coming, we are encrypting it, storing it in the DB, and we are sending it to the client. That is fine. But during decryption, here once the short URL is coming, we are checking the database each and every time to find out the long form of the URL that is associated to. Means here we are still having the issue of latency, because I already told you scanning a database is an expensive job. So somehow we have to optimize it. And the way we can optimize it is we will introduce another caching layer over here. Means we will introduce another Redis cluster over here before the database. Means once a shorter URL comes from the client, it will first check the Redis cluster that whether the mapping of the long form of the URL is present on the Redis cluster or not. If it is not present, then only it will go to the database. Otherwise, it will only see the Redis cluster, and from here only it will send the response to the user. So here if you see, we have optimized this solution drastically, because here with the previous approach, since the access time of the DB was 10 milliseconds, so to decrypt a URL, what it was happening, maybe a 5 millisecond was required to come to our server, and then we are again using a 10 millisecond to retrieve the value from the database, and we are returning it within 16 milliseconds. But with this new enhancement of the introduction with the Redis, here since Redis server is very quick, probably it will take around 2 milliseconds to get you the long form of the URL, and thus we have optimized our solution from 15 milliseconds to just 7 milliseconds. I hope this is clear. And remember, all this data I am telling is just a mock-up data. These are not the actual real-time data how the server or a database takes. Here, just to explain you the scenario, I am just putting some arbitrary number over here. So, I hope you are clear with how we can solve the problem of shortening a long form of the URL to the short form with these two approaches over here. And I am pretty sure that you right now know what can be the pros and cons of each solution. So the problem for the last solution was, here was the Redis cluster. Since here we have the single instance of the Redis, it will not be able to scale properly. And here if we are using a cluster of Redis, then there will be again a problem of maintaining the counter value properly. So let's move to the last and the final way of implementing, and maybe probably the best solution available, and that is with the help of a distributed system coordinator called as Zookeeper. So let's see how we can solve this problem with the help of the Zookeeper, and how we can get rid of all the constraints that we have explained so far. So let's go with the third approach, and that is solving the problem with the help of the Zookeeper. So now before going into the solution with the Zookeeper, I have to tell you that what is a Zookeeper and what it actually does. So before we start, let me tell you what is a Zookeeper, because without understanding some basic concept of Zookeeper, it will be very difficult for you to understand this implementation. So the definition of a Zookeeper is, it is a distributed open source coordination service for distributed application, providing centralized service for configuration management, naming, synchronization, and many more. So basically you can think Zookeeper as a monitor for all the distributed things that are happening in a distributed system. So for example, you have multiple services running on your backend, and all of them are managed by a single parent element, and that is zookeeper. So overall, understand this concept that zookeeper acts as a monitoring service for all the services that are running in a distributed system. And why we use a zookeeper? We mostly use a zookeeper for maintaining configuration, naming, for providing synchronization, for distributed locking, and many more services. So this is basically the main concept of zookeeper. I hope you are clear with what is a zookeeper. Now I will tell you that how you can register your application in a zookeeper in a very layman's term. So the way Zookeeper memorize all the services or register all the service in their memory is like a tree structure, or you can say it is same like the directory structure that we have in our computer. So more or less it saves all the data in this fashion. So let's take an example. This is your Zookeeper, and here this is the parent node of the Zookeeper. Now you are registering two applications within the Zookeeper, so it will create two directories over here. One is this one and another is this one, and this directory is the app one, which will have all the configuration, all the elements of the application 1, and similarly for the application 2, all the configuration and everything will be stored in another directory. In this way, Zookeeper keeps all the data of a particular application in the memory in a hierarchical form, and whatever the data or the configuration you save for a particular application will be there within this respective folder. And remember, Zookeeper have two type of directory or the folder structure in its ecosystem. One is called the persistent node, another is called as ephemeral node. So these are basically called the node of the Zookeeper. Now what is the difference between two? A persistent node, as the name suggests, can never get deleted from the Zookeeper system. But a ephemeral node can get deleted whenever it is required. So what happens is, like, whenever you register an application in Zookeeper, that application gets created in the Zookeeper ecosystem as a ephemeral node. Means till the point the application is live and running, this ephemeral node will be active. But once your application restart or died, then this node will get deleted, and whatever the configuration that was there in this ephemeral node will also get lost. I hope this is clear. So we have two type of nodes. One is the ephemeral node, another is the persistent node, and persistent node cannot get deleted, but a ephemeral node can get deleted whenever your application dies. And how Zookeeper check that whether your application live or not? It sends a heartbeat request to your application, and whenever it checks that heartbeat of the application timed off, means your application is not responding to the heartbeat, it identifies that your application died, and that's why it drops this ephemeral node from the root element, and it identifies it that application or server died. So this is overall how Zookeeper works. Now let's see, using this concept, how we can enhance our this design and how we will solve this problem. So let's start with modifying and enhancing this entire logic with the help of a Zookeeper. So this was our previous design, and the main concern over here was this Redis node. So what we will do, we'll get rid of this Redis node for our next implementation. And here what we'll do, instead of a Redis cluster, we will introduce a Zookeeper over here. And this Zookeeper will be solely responsible to monitor this cluster of encryption service. Means it will check which service is up and running and at what time. Now what we will do, here within this Zookeeper, we will keep a counter. Okay, so initially what we are doing in this application, we were creating the counter in the Redis, but here we will create a counter variable within the persistent layer of the Zookeeper. So it is quite clear that by anyhow, this counter cannot get deleted. Now what will happen? The counter that is present over here, we will not use the counter the way we were using in this implementation. But here we will do something more logical and extra so that our designing of the system becomes scalable, robust and reliable. So let's see what we will do. So here what happens is, like, whenever you register a server on the zookeeper in return will give you a worker ID. So for example, here we have 3 server. So here we will be having 3 worker ID. Let's consider first worker ID is 123, second one is 234, and the third one 345. So these are some arbitrary number. So since here our goal is to create a unique key, we will see how we can create a unique key based on this concept. And here to create a unique ID, we will follow a particular template which is called as a snowflake ID, which is very commonly used in a distributed system to generate a particular unique ID. So let me tell you what this snowflake ID tells. So a snowflake ID is a unique ID that is a 64-bit long. So let's see how it is formed. So here if you see, this is a 64-bit snowflake ID, where the first bit is a sign bit, means positive or negative. Then the next 41 bits is the timestamp of the machine. Next, the 10 bit is the worker ID, and next 12 bit can be any random number. This is the concept of the snowflake ID. Now what we will do, using this concept, we will create a unique ID for each and every machine. Now why we are doing this and what problem it will solve, I will tell you clearly once we understand that how we are solving this problem. So just bear with me for 5 minutes. So here if you see, we have to create a snowflake ID. So what we'll do, here first is a sign bit. So here we will assign a positive sign bit. So it's not a problem to assign a sign bit over here. Next what we need a timestamp. So each and every server will obviously have a timestamp. So that will be our 41-bit timestamp. Next, what we need a worker ID. Now from where we can get a worker ID? This is what our zookeeper is giving to us. And next, what we need a random 12-bit number. And from where we can get this 12-bit number? We will get the random ID in the same way by which we have solved our previous problem. Means a counter value will be present on each and every server locally within the machine. Means each and every machine will have a counter over here. Now you might be thinking what will happen when the server restart. I will tell you all those things very quickly. So what we'll do right now, we will create a counter value again within our each and every servers over here. So here we have got everything, the worker ID, the timestamp, as well as the counter for each and every machine. So here our entire snowflake ID got created, right? So right now each and every machine which is registered and up and running have a unique snowflake ID for each and every request. So let me tell you how this flow is working. So whenever you are setting up a server in your backend, a snowflake ID is getting generated. So each and every server have a snowflake ID and the value of the counter is set to 0. Now, whenever a request is coming from the client, what is happening? The server is adding up or concatenating the worker ID which it already have received from the zookeeper. Also, it is adding up the timestamp when it got the request, and also this counter value which is already there in the local. So by anyhow, whenever a request comes, we do not have to go to a third-party service to generate the request. So everything is happening locally. So here if you see, we have reduced the latency further. And right now we are not even making this call to generate your unique ID. So whatever is happening locally within your application. So our request time got reduced significantly, and we can ascertain it that the snowflake ID that got generated or that will get generated on each and every server will be 100% unique on each and every request. So this give you a bulletproof solution of how to generate a unique ID within your application. Not even we are calling any external services. So we have drastically improved our application by serving everything locally within the server. Now the question will come that what if zookeeper fails? So zookeeper doesn't fail anytime. Means even the zookeeper fails, it is not a problem, because Here if you see, we are not making any call to the zookeeper because the zookeeper is only getting called once your application is booting up, once you are registering your service. At that time only you are calling the zookeeper. So by anyhow, we are not using this zookeeper on each and every request. But even if zookeeper wins down, zookeeper have the capability to get this counter value from its log. So this counter value will get persistent since it is on the persistent layer of the zookeeper. So this way of implementation can never fail. Now let's see what will happen if one of the server dies over here. Now if one of the server out of 3 dies, what will happen? The load balancer will send the traffic to only the 2 servers that are still working. And at that point, the server 3 can boot up again and it will fetch the new worker ID from the zookeeper and it can regain its entire configuration within a couple of minutes. And once that service is up and running, the load balancer will again send the traffic, and since the worker ID is unique, the counter is unique and the timestamp is unique, so it can again perform the way it was performing just before it got died. So believe me, this might be a bit overcomplicated or maybe a over engineering thing for this simple solution or a simple problem statement, but with this approach you can 100% rely on your service. So I hope you are clear with how the system is working over here. Now the question is, now what we will do with this 41-bit Snowflake ID. So what we will do, we will again encrypt it and we will follow the same principle that we have done for this one. That is, we will again go back to the first logic that we have implemented. That is, this 41-bit Snowflake ID will get encrypted by SHA-1 or MD5, and from there we will get the first 6 to 7 character and we will send it in response. Now the question will come, then what was the problem with this first approach? Now let me tell you what was the problem. So if you look carefully, the way this MD5 hash generator works is like a key value pair. Means you are providing a key over here, and based on this key that you are passing into this encryption logic, it will give you some value over here. Now what it can happen in this predefined libraries or so. So for example, we have 2 URL which are more or less similar over here, and maybe there is 0.001% chance that whenever a user is passing the 2 URL almost similar, means there is only a 1 or 2 character difference in them, it will result into almost similar MD5 result over there. And since we were only chopping off the 5 and 6 character from the beginning, and at that time on those test case we will fall into the problem of creating the duplicate records in our database. Now what will happen in our new scenario, the key that you are passing into the MD5 encryptor is completely in your hand, because the Snowflake ID that you are passing to this MD5 generator, it is created by you, and you are 100% sure that that will be unique, and also you are sure that you are actually using a broader spectrum of keys, and the possibilities of generating a almost duplicate hash is very less, probably none. And that's why we should go with this approach, where we have the opportunity of handling the key by ourselves, so that there is less possibility or zero possibility of creating a duplicate key in our application. Hopefully that makes sense, that why over here we are going with a hybrid solution of combining all the 2 or 3 approaches together and creating a resilient solution to solve our problem. So hopefully you have got the clear understanding of this solution. Now let's see whether we are left with any other functional requirement or not. So here if you see, there are a few more requirements that are pending, that is creation of this custom URL and expiration date. So this will be a very simple logic. So what we will do here, whenever it is a default flow, what we have to do, whenever we are ingesting in the database, we also have to set the date and the expiration date in the database. And here we will have a cron job, something like this, and this cron job will run once in a day and it will delete all those records that are expired. So this is applicable for all of the designs over here. And one more thing, also remember, whenever we are creating our cache, over there also, each and every entry of the cache should be present with the expiration date as the TTL. Means, for example, though the cache will get evicted if it is not used for a longer period of time, but in case the URL is getting hit each and every day, but it have to get expired at some point, right? So you should have to set a TTL for that record in the Redis cache so that after 30 or 90 days, that entry should get deleted from the Redis cache as well as from the database, which will get deleted by the cron job. Otherwise, the cron job will delete the entry from the database, but since that URL is a hotkey, that is why the entry will be present in your Redis and your user will get benefited from that, and which we do not want in our application. Now, the next thing is like we have to create a custom URL, and that is also very simple because here in case of generating a custom URL, we are not using this logic. Means if it is a premium user, what we will do? We will simply check that whether the entry is there in the database or not, and if it is so, we will allow him to do the custom URL. Otherwise, we will tell that this custom URL already exists in our database, so you have to choose something different. So that will be a simple flow. Now let's see what are the other things that are remain. So here if you see, we have already taken care of all the non-functional requirement, the low latency, the scalability, the shortened URL should be unique, and also the availability better than consistency. And here also if you see, we have covered all the functional requirement, and the only thing remain is this one, and that is the user redirection. And how we can achieve it, we have already discussed over here that we will have a decryptor server over here which will decrypt our short URL to a long URL just by seeing the database or by seeing the Redis cache. But how it will do? Once it finds the entry in the database or the Redis, it will send the response to the client with a HTTP status code of 301 or 302. So these are the two status code for the redirect URL. Because obviously, you know, we have to redirect here from the shorter URL to the longer URL. Now, there are two possible ways we can achieve this. One is by using a 301, or otherwise we can use a 302. Now, what is the difference between two? There is not a much difference from the user aspect, but only a small thing is like a 301 is a permanent redirect. Means, for example, using this bit.ly encrypted URL, if I have already used it in our browser, the browser will save that history of this mapping between the short URL and the long URL in the local cache, and thus the request of decrypting will not go into our server. So with the help of the 301 redirect, you can decrease the total number of calls that are coming in our decryption server. But if you are using a 302 redirect, whenever a client or a user hits your encrypted URL, it will come to our server, we will decrypt it, and we will return the response in return. So this is the core difference between the 301 and the 302 redirect. Now, which one you should implement it? Discuss this with your interviewer, because with the help of these two, you can also implement something additional. That is, for example, you want to decrease the traffic in your service. So at that time, you can go with 301 redirect. But in case you want to log your data and you want to do a AI ML model out of it. So for example, a premium user want to see that how many of his customer has used or hit the custom URL. Obviously, for that you need a dashboard or something like that, and for that you have to use the 302, because if you are going with the 301 redirect, the request will never reach our server, so we will not able to track that how many user or how many times that URL got hit by a particular user. Now, the last but not the least, what will be the type of database that we will be using? So here you can see this is not a very complex things to save. We are just saving a key value pair along with some expiration and creation date. And for that, you do not have to think too much. You can simply go with a Postgres or a MySQL database. But remember, though over here we have created a cache to reduce the total number of hit in the database, but still for the first time it will get hit in our database, right? And for that, what we have to do, we have to do a proper indexing on our database, and we will create a indexing on this short URL. So this will be our primary key, because each and every time whenever someone is trying to decrypt the URL, obviously he will send a tiny URL, and that you have to check in our database and give the long form URL in return. So our indexing should be definitely on this shorter URL. So hopefully you have thoroughly understood this video and you have found this video useful. And if you have found this video useful, do not forget to like, share and subscribe to my channel and hit the bell icon so that you never miss an update from my channel and you are always ready for your next interview. So see you on our next video where we will solve another system designing problem in much deeper, and we will see how you can build a highly scalable, highly reliable and a consistent system during your technical interview. So see you on our next video. Thank you.